Hey, I wanted to start out today by making sure that we understand the directions of slope. In other words, what does slope mean? If we see a slope, being able to tell how it can help us get from one point to another when we're graphing a linear function. Remember that slope means change in y over change in x. That means that the change in y tells us where to go, either up or down. It actually tells us whether a line is increasing or decreasing as it goes to the right. The change in x tells us where to go, left and right. Specifically, it tells us how a line is changing as we move to the right, from left to right. So let's take a look at what the following slopes mean. If I see a slope of 3/2, that means that I'm going to go up 3 for every 2 units I move right. A slope of -1/2 would mean that I go down 1 for every 2 units that I go to the right. A slope of 3, which is really 3/1, will tell me to go up 3 for every 1 unit I go to the right. A slope of -1, which is really -1/1, would tell me that a line is going down 1 for every 1 unit I go to the right. So being able to convert a given slope into directions on finding solutions or points on a line is really a very important skill. What I want to do now is basically show you why that skill is important. In order to do that, I would first like to graph the function y equals 2x plus 4. Now remember, we've done this with tables before. Let's do it again. Remember, when we are graphing a linear function, we use the common domain if no domain has been given to us. That means we use the numbers 2, 1, 0, -1, and -2 as our input numbers, and then we figure out what our output numbers are. In this case, we want to multiply by 2 and add 4. When we do that here with the common domain, we get the following range. And remember, together, the domain and range give us points, and these points will represent numbers that make up solutions to this function, which we can graph on the right. So we graph 2, 8, we graph 1, 6, we graph 0, 4, we graph -1, 2, and finally we graph -2, 0. And I'm reminded that this is a linear function because all of the points are lining up in a straight line. And remember, this straight line not only represents the solutions that are on it, but also all of the numbers that this line will pass through, which is basically an infinite number of ordered pairs. Now, I want to point some similarities out between the function and the actual graph, this line right here. The first thing I want to do is find the slope of this graph. I'm going to use rise over run. I know that this graph is going up 2 for every 1 unit it goes to the right. And no matter what 2 points I look at, that is always going to be the case. So the slope of this line is 2/1. It goes up 2/1, up 2 to the right 1, up 2 to the right 1. Interesting. The slope of this line is 2/1, and there is a 2 in this linear equation. The second thing I want to point out is a very special point on the graph, and that is this point right here. I'm going to make it yellow so you can see it a little better. I don't know if you remember, but this is a very special point. It's where the line crosses the y-axis. It's called the Y-Intercept. In this graph, it's the point 0, 4. Interesting. The Y-intercept is 4, and there's the number 4 in this linear equation. People, these two things will always be true when an equation is written in function form with y by itself. So we figure out that the slope is 2 of this line, up to right 1, and the y-intercept is 4. And the equation y equals 2x plus 4 shows both of those things, which is why when a linear equation is in function form with y by itself, we call it slope-intercept form, or y equals mx plus b, where m, the number that is the coefficient of the x, is always the slope, and the number being added we call b, which is always the value of the y-intercept. So if you remember from earlier in the year, ax plus by equals c, this is known as standard form. This means x and y on the same side. Slope-intercept is when y is by itself. Y equals mx plus b, where m is the slope and b is equal to the y-intercept. The reason why this is important is because now I can look at any equation in y equals form and automatically know the slope and the y-intercept. Take a look at y equals 3x plus 4. 3 is the slope and 4 is the y-intercept. If I know these two things, I can make a very quick graph. My y-intercept will be 4. That's where the line is going to cross the y-axis. And my slope is 3, which is the same as 3 over 1, which is the same as up 3, right 1. So I can make my line by going up 3, right 1. And if there's no more room to go up 3, right 1, I could actually do the opposite and go down 3, left 1. Down 3, left 1. And I should have 3 or 4 points before I draw my line. This is great because I don't even have to make a table. We can graph a linear function without a table, without 5 values, without the common domain, just by looking at an equation in y equals form, also known as slope-intercept form. Nice job.